Hey guys, welcome to another lesson. So today we're going to do another video in the nice question series. Today's question comes from the Extension 2 syllabus in the topic of complex numbers. So I thought I'd pick a question that has a lot of marks and generally has a lot of marks in exams relating to complex numbers mixed with polys and trig. If you find this question, it's generally near the end or near the back end of the paper. So consider to be, a little bit harder. And certainly the marks reflect that. Now, before I go on, if you haven't already done so, please like the video, subscribe to the channel, and tell your friends. So let's get started. So this question is from Sydney Grammar. You can see there, 9 marks in a 4-unit paper. That's a lot of marks, right? In essence, if you couldn't do this, you're on the back foot. Be quite hard for you to get quite a high rank, right? So make sure you can do questions of this caliber. Now, I picked this one for 2 reasons. One, it's paragraph 7, right? For those that usually do this, it's paragraph 4, paragraph 3, paragraph 5. Paragraph 7 is quite hefty. So part 1 and part 2 with 3 marks together just takes a lot of steps. It's a bit tedious, but not too hard. Part 3 is a classic. Part 4 and 5 I really like, especially part 5, right? Just to basically use polynomials mixed with trig to do it. So let's get started on this question. So for those that haven't seen this before, it's your classical sort of question where you expand this using binomial theorem. And then when we combine it with the Moivre, comparing coefficients, you will get an expression for sine 7 and cos 7. And once you do that, sine divided by cos gives you tan to give you the thing that you want. Replace strategically to do part 3 and then using polynomials to do part 4 and 5. So you know what? Enough of me chatting on. Let's get started. So cos plus I sine theta, power of 7 using binomial. Now, oops, too far across. Let me come back. So I know using Pascal's now. Okay, actually, let me get Pascal's triangle. So I know the last one I recall off the top of my head is 1, 4, 6, 4, 1. So it's 1, 5, 10, 10, 5, 1, 1, 6. So I'm just trying to get the coefficients of expansion, right? So 15. Actually, you don't need to do this. I can use, let's just be smart. Sorry, I was going to do Pascal's, but no. It says using binomials, so might as well go. Okay, NC, so 7, C0, right? Cos 7 theta plus 7 C1. Yeah, we'll punch that in later. That's cos 6 theta times I sine theta plus 7 C2. So like I said, it's a bit tedious, right? But let's go through the motions and get our 1 mark, right? Squared plus 7C3 cos 4 theta I sine theta 3 plus 7C4 cos 3 theta I sine 4. It's super tedious, isn't it? 7C5. It's 8 terms, Jesus. Cos squared I sine 5. Almost there. 7C6 cos theta I sine theta 6. And then lastly, I sine theta 7. Okay, that was fun. Not really. Now, so that becomes, now, you know what? They ask me to prove. Oh, no, damn. They didn't give me the answer. So that's just cos 7 theta. Now, this guy is positive 7 I cos 6 sine theta minus, right? Because I squared. Now 7C2. I'm just going to look at the next part to let me know what the coefficients are. 7C2 looks like, I'm going to hazard a guess to say 21. Someone, all right, I'll do it. 7C2, 21, surprise, surprise. Cos 5 theta sine squared plus, and I guarantee you 7C3 is 35, 100%. Let's just go there. And then cos 4 theta. Now, where's the i's actually? So this one has an I and it's got a minus. So be smart about that. So minus, and guys, let's go here. 35i, right? Because it's I cubed, right? Sine cubed, and then becomes positive again because it's power of 4. And that's another 35 because it's symmetrical, combinatorics are. Right. Sine 4 theta, and then minus, right? Because it's, sorry, plus, but there's an I in front. And 7c5 is 21 again. I cos squared. Very easy to make a silly mistake, isn't it? Just be really careful if you're in exam. Now, I squared, right? That's minus 7 cos theta, sine 6 theta. And lastly, let me shove over here. Now, this is an I7, that's like I cubed, so it's minus I sine 7 theta. All right, wowzers. That was fun. Right, once we got that, part 2 for 2 marks, I now need to expand this and then prove it with de Moivre. So this is binomial, the same expression using de Moivre puts the angle in, puts the power inside the angle as 7 theta plus I sine 7 theta. Now, and then we compare our reals and imaginaries because both of these are equal, right? So then, all right, let's pick up my reals. Real, every second one, right? Real, 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 and imaginary, 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 imaginary. Now, compare that to de Moivre. That's real and that's imaginary. So what I need to do now is compare my blues and compare my pinks and then get the expressions for sine and cos. So let's go there first. Comparing real parts. And I got cos 7 theta equals to cos 7 minus 21 5 sine squared plus 35 shove over cos 3 sine 4 and minus 7 sine cos 6. And then same thing, so comparing imaginary parts, right? I got sine 7 theta. So if this was in a test, I mean, it's good because you're getting marks for like just tedious work, but not hard. Now drop out the i's, so you get sine 7 theta equals to 7 cos 6 theta sine, and then minus 35 cos 4 theta sine 3 theta, and then the other pink there, 21 cos squared sine 5, and lastly plus. So plus, it's minus, isn't it? Is it? It's minus. Yep, sorry. Minus sine 7 theta. All right, cool. Now, and then you go, once you get sine and cos, they want tan in this question. So therefore, tan theta, or sorry, tan 7 theta equals to sine 7 on cos. So guys, I'm a little bit lazy, so I'm just gonna copy. Let me there need to be. Just gonna ungroup it. Take that guy. Yeah, that's my numerator. Take this guy. That's my denominator. Put a big line between them. Oh, totally missed it. Yeah. Now, once you're here, the aim is to basically, the question says make them all tans, is that right? And the trick is always, once you have those two expressions, divide by the highest power of cos. So cos 7 theta to top and bottom. Every term, right? Every single term, divide 1, 2, 3, 4, 5, 6, 7, 8 by cos 7, and you'll get it, right? Yeah, so let's do that. Yeah, one piece at a time. So on the top, I get, let me make sure, divide by 7, I get 710. Is that right? Yeah, perfect. So because cos 6 divided by cos 7 is cos, and the leaves sine and cos, so that's 710. Minus, divide that by cos 7, you get cos 3 on the bottom, so 35 tan cubed plus 21. Cos squared comes out to cos 5 on the bottom, so that becomes tan 5. And then sine 7 on cos 7, that's tan 7. Cos, that's 1. Leaves 21 tan squared plus cos 3 divided by cos 7 cos 4, sine 4, and cos 4 is tan 4. And lastly, cos 6 divided by cos. Wait a second. I get that right. A bit nervous because I know I didn't. I swapped, for some reason, I swapped sine and cos around. Ooh, I must have done that up here as well. So let me quickly fix that, otherwise it'd be erroneous. Yeah, that's cos. Yeah. And this is cos. This sine, yeah. Because when I divide by cos, I get tan, or 7, tan 6 theta. Now, quick glance at what I have to prove. Did I prove it the same? I say 7, 6 cos. Yes, 7, 5. 7 minus 35 plus 21. Perfect. All right, good. Is that okay? Now, I spotted that error because I always write the sign. I should always write the sign at the back. Got it. So therefore, tan 3 theta equals that. Yeah, beautiful. That was the first 3 marks out of how many? 9 marks. Okay, cool. Now, I like the next part, right? I really like explaining it to my students because the next part is quite fun. Yep. Now, if you look at the question itself, right, you know what? I'm going to make a copy of this question so I don't always have to scroll up. Just bring it down. Oops, brought both down. Yeah, I'm just going to crop the part that I want. Let's just crop. Oop, that wasn't what I wanted. Okay. Come on, PowerPoint. Yeah, crop that. Move that down here. Okay, check this out, right? So I want this equation, right? Now, where does this equation look familiar, right? If you look at it, x6, 21, doesn't that look a little bit like these coefficients, right? It does, right? So this is the game plan, right? Now, from upstairs, I actually get this guy, get the green, no, where's my green pen, right? Green pen, I actually get this guy by factorizing tan out, right? And I'll get something similar because if I factorize tan out, I'll get 7 minus 35 tan squared plus 21 tan 4 minus tan 6. And that's exactly equal to this guy, but with opposite signs, right? First thing I note is that the coefficients and that guy look very similar. Second thing I note, on the other side, it's 0. So I'm going to be very strategic about this, right? And I'll pop this question up over here, if that's okay. Because I'm going to say, for this one, I'm going to do a double substitution, right? A double substitution. On the right, the left-hand side, I'm going to let tan 3, what is it? 3, 7, yeah? Tan 7 theta. Let tan 7 theta equal to 0. Why is that cool? Because the denominator multiplies with 0 and goes away. And then on this side, I'm going to go and let tan theta equal to x. This is cool because what I'm going to do now is use this strategic sub sub in 0, solve the blue side first for my thetas. And then on the right-hand side, I'm just going to let it be x, right? So it becomes like this, right? I'm going to, let me solve this blue one first, right? So I get tan 7 theta equals 0. Now, we know that if that's the case, then 7 theta would equal to 0, pi, 2 pi, 3 pi, etc., right? Just keep adding 360. Now, we're going to be smart. Instead of letting it equal to pi, so we're going to go plus minus pi, plus minus 2 pi, plus minus 3 pi, right? Now, how many solutions is that? That's 7, right? Perfect. And then divide everything by 7. Therefore, theta is 0 plus minus pi on 7 plus minus 2 pi on 7 plus minus 3 pi on 7. Perfect. 7 solutions. Now, the moment I let tan theta equal to x, I get this equation, right? I get, and I'll do it in green here, I get 0, right? Because I've let it be 0 on the other side. 7x minus 35x cubed plus 21x5 plus, minus rather, x7. Okay. Now, you can see almost there, I'm going to divide everything by negative x. And so therefore, I get x6, right, minus 21x4 divided by x, which means bring it over and then divide by x, right? Yeah. Actually, no, instead of dividing, I'll factorize x out, right? So take out the x. So just to illustrate that there is another, there's 7 solutions. And plus 35x2 minus 7 equals 0. All right. Now, I now have a power of 7 polynomial with 7 solutions, but I actually already found them, because if I say let x equal to tan theta, I found tan theta. These are my tan theta. I found theta. These are my thetas. I'm just going to sub them all into the theta and go, therefore, x equals to, sorry, I'm freestyling here. What am I doing? Am I solving? Yeah, solve. Sometimes I just get carried away with the concept. So therefore, I don't need to further solve this polynomial. I already solved it because I found all the thetas and I let x equal to tan theta. So then x therefore equals to, now tan 0 is just 0, right? Which actually is the solution to this guy, right? Yeah, so that guy there has this solution. And the 6 solutions over here become tan, pi on 7, tan, negative pi on 7, right? Now, just before I write this, tan negative pi on 7. That's like tan in the 4th quadrant, right? Yeah, that's the same as negative, right? So negative angle in the 2nd quadrant, so in the 4th quadrant, that's like negative, because tan is negative in 4th quadrant, because then I'm going to just shortcut the answer and write as, if that's okay with you. Let me ungroup this first. I'm just going to do this, move this forward slightly, and go plus minus. So instead of having the plus minus on the angle, so I have to write like 7 answers, I'm going to combine 2 answers there, plus minus, and then plus minus tan 2 pi on 7, and then plus minus tan 3 pi on 7 as well. So guys, I have 7 solutions. The 0 belongs to the x, and for the polynomial of x6, whatever, I have those. Now, the question only has x6, so I actually don't need the first part. I don't need the first part. I thought I'd put it to you there as an illustration. These 6 are the answers that they want because they relate to this polynomial. Is that okay? So whenever you do this question, you got to strategically sub the blue to let it be a number. Sometimes it might not be 0. Sometimes it can be like 1 or something and bring. So if it's if I see more than 4 terms, like in this case, because it's 4 on the top, 4 on the bottom, if I let it be 1, the 4 terms on the bottom come up, that becomes like a 8-term polynomial. That's not what the question says. The question only has 4 terms. So I let it be 0 and only deal with the numerator. Okay, once we solve that, let's keep going. Now, I don't have any more space, so let's go to the next page, where I also have a copy of the question. Now, the question says, using product of roots, do that? Cool. So just to be clear, my for part 4, 4x6 minus 21x4 plus 35x squared minus 7 equals 0. The roots are plus minus tan pi on 7, comma, plus minus tan 2 pi on 7, and plus minus tan 3 pi on 7, right? Now, using product of the roots, I know that it'll equal to, let's see, if this is, so be a x6 plus b x5 plus c x4 d x3 e x2 f x plus g equals 0. Now, product of the roots minus plus, so this is minus plus minus plus minus plus. Is that right? Yeah, minus plus minus plus minus plus. You just check that. Cool. Yeah. So therefore, product of roots, I multiply all these together. So that the first two would be minus tan squared pi on 7 times minus tan squared 3 pi on 7 times minus tan squared 5 pi on 7 equals to minus g, so minus, no, equals a positive g, so minus 7 on a. Yeah. Now, that's going to give me negative of tan squared pi on 7, tan squared 3 pi on 7, tan squared 5 pi on 7 equals to negative 7. And then the answer that they want. Now, firstly, I can see that the negatives go away. And I'll square root it. Now, when you square root something, obviously there's plus minus. But for this question, right, let me ask you this question. Why is the answer only positive? Yeah. Oh, I copied that wrong, right? It should be 10, 2. Is it 2 and 3? Yeah, whoops. Don't know why I changed it to 3 and 5. Went up by odd numbers. Yeah. Shouldn't be odd. Should be just 2 and 3. Perfect. 2 and 3. Guys, why is it just positive root 7 and not negative? Because each one of those angles here of pi on 7, 2 pi on 7, 3 pi on 7, they're all less than 90 degrees, right? Because 3.5 on 7 is half, which means they're all in the first quadrant, right? So therefore, it equals to pi on 7 only. Pi on 7, oh, sorry, pi on 7. It equals to root 7 only, right? Only positive, because each one of those are in the first quadrant. Is that cool? Now, part 5, last part to this question. That's nice, right? Using polynomials and this. Using a careful argument involving roots to determine the value of that. Now, this one's harder because you can see in this case, right? You can try to use like the roots here and try to determine like, I don't know, one on something is too complicated. Instead, we're going to do this, right? x6, I'm just going to copy down our polynomial, right? The fact that for this polynomial, the fact that they're all in squares, right, actually is the key. Because I'm going to repackage this equation in terms of x. I'm going to let x squared be factorized. So that minus 21x squared plus 35, well, x squared minus 7 equals 0. And I can see, right? I can just say where the roots used to be x. In this case, this forms a polynomial, right? Where roots are tan squared pi on 7, tan squared 3 pi on 7. So keep going up by odds. 2 pi on 7 and tan squared 3 pi on 7, right? I can say that, right? Because upstairs I got that 2 of the roots together are tan squared, right? So tan squared should work because tan pi on 7 should be a root. Yeah. So in this case, then I can say, therefore, so this is like alpha, this is like beta now, this is like gamma. So instead of a power of 6, I'm dealing now with a cubic, right? Where if I say sum of the roots, yeah, because the reason why I'm doing this, and therefore, maybe I don't have space. Can I mean, I've got so much space on the other side. Can I just, let's just shuffle. Perfect. The question says, I want some of the cot squares, right? So the question says, cot squared pi on 7 plus cot squared 2 pi on 7 plus cot squared 3 pi on 7. Just quickly look at it. Yep. Right. In terms of, if this was alpha and beta, right? That's just 1 on alpha plus 1 on beta. Yeah, it's just the reciprocals, right, of my roots. Yeah, which we know using common denominators, right? Alpha, beta, gamma, and some of the doubles upstairs, right? Sorry, I'll do it in the actual order. Right? So I just get those two from upstairs. So I know up here, right? Go back upstairs here. The sum of the roots is equal to minus b on a, so it'd be minus negative 21 on 1. That's 21, right? And I know that alpha beta plus alpha gamma plus beta gamma is equal to c on a, that's 35. So then sub that in, right, as your answer. Now let me make sure. Oops, did I do that wrong? Oh no, I don't want sum of the roots. I want product of the roots. Not sure why I did the sum there, right? So I can see down here, I need the double and then I need product. So alpha, beta, gamma equals to negative plus negative, so negative, negative 7 on 1, 7. And then my final answer is just going to be 35, oops, 35 on 7, which is a big fat 5. That was nice. So the last two questions are really cool because it utilizes polynomials mixed with trig, always going to be hard. So the first part 1 and part 2 and part 3 are very textbook. And then part 4 and part 5, using polynomials enriches this question to give it a bit, it makes it very wholesome, right? And 9 marks, most importantly. Guys, hopefully you liked the video. Like the video, subscribe to the channel, and tell your friends. I'll see you in the next one.